So, how do we write a base protonation constant expression? Well, the first thing you got to realize is what happens when a base dissociates. Well, base is a proton acceptor. So, even if we've never seen the base before, we should be able to write the formula for its conjugate acid. So, for any base, AQ, it will react with water, which of course is liquid. So, it's going to accept a proton from the water. So, we can just stick an H plus to our base, the H plus, let's call it. So it doesn't matter. I've never seen this 4-bromo-aniline before, but I know if it's accepting a proton from the water, I'm going to add a hydrogen and a +1 charge to its formula. So I'm going to get that conjugate acid, BH plus, and what is left behind of the water, H2O, if I take a proton away from it, is going to leave OH minus. So that's what we have there. So I could write a generic base protonation constant. You've always got to write your balanced chemical reaction first, right? So Kb is going to take the form of the concentration of the product. So that would be my conjugate acid, BH plus, whatever that may be, times the concentration of my hydroxide divided by the concentration of my weak base. Okay, obviously watch for stoichiometry, etc. But most of the time you're going to find you've got a nice simple one-to-one stoichiometry of everything. So the Kb expression is pretty simple. So let's look at this 4-bromo-aniline. C6, I've got to look at the formula, H4, BrNH2. Hi, plus water. So water will donate the proton to my 4-bromo-aniline. So that formula then is going to be C6H4BrNH, and now we've added an H plus to it, so it'll be NH3, and don't forget about the charge, so NH3 plus, and water, after it's donated its proton, just leaves behind the hydroxide ion. So to write the Kb expression, concentration of each product raised to the power of its stoichiometric coefficient over the concentration of each reactant raised to the power of its stoichiometric coefficient. So that Kb expression will be my conjugate base conjugate acid C6H4 BrNH3 plus times hydroxide over my weak base C6H4BrNH2. And of course, water does not appear in the Kb expression because water is liquid, not aqueous. So we've got to follow heterogeneous equilibrium rules. All right, so hopefully that is helpful for you guys. You can write the base protonation constant for any base. We cannot.